So on the skills checks, and I'm figuring this out as we go along. Literally figured out what was gonna happen like at 1 o'clock today. So you got, here's the scores you can get. And then there's, so these two scores mean good enough. You don't have to retake it. 10 is like, wow, you freaking nailed this. You like got everything. 9 is, there's some things that I've commented on, take note of this. You know, you don't have to fix it though. One thing that you should know that maybe you didn't know, I'm actually positive you didn't know it, is you don't have to do every problem on the worksheet to get a pass. So like if you do like all but one, good, that's good. That's sufficient knowledge, but you have to do them well, right? So these are okie dokie. And then this, there wasn't a lot of 10s, honestly, but that's okay. There's a lot of 9s. And then this one is needs revision. So, let me get this all up here. This means you need to fix the things that you submitted and staple corrections. You don't have to come retake the whole dang thing. Submit corrections within a week of it. So what I ask is that you redo the problem on a separate sheet, staple it to the back, and then resubmit. Alexander, you look baffled by that.
You gave us an answer key though.
I removed the answer key. Yeah. Did you copy the
No,
answer
I
key?
was looking at it today.
It's
so
cool.
like,
No, and that's fine. That's fine. We're all figuring this out, you know, but yeah. And then this is, you need to retake it. So yeah, you just didn't put enough down, or you left blanks, or just what you put down was pretty far off from what it should be. And so this is the only time when you get a 1 on it, and it says like redo. I forget what it says. I'm not gonna go look at somebody's paper. You'll see it on there. But like it says like not enough or something like that. And so this is when you have to come figure out a time to come take it with me. We'll set you up in the math office, something like that. And I'll give you a freshen to work on. So let me get this back to you. I hope that makes sense. Oh, and then, you know, these are the same. These are the same grade. They are check mark, you passed. You passed. And that's all you need. You need to pass whatever the number is in the syllabus of these skills checks. Okay. Cool, so just come around here. I can't have anybody help me because FERBA, and these are all separated, and oh God, it's a mess. This is gonna take like 15 minutes. Oh God. You're welcome. Sorry, my friend. And in the future, I will fix these up.
No.
Oh, sorry.
No,
I'm
that
so
was
sorry.
not my fault. I should have been more mindful.
You know, you were great. I should have been mindful. Mr. Daniel.
Yes.
The other Daniel, sorry. I'm sorry. I was speaking to the ghost Daniel.
Oh.
Yes. Mr. Ross. Alexander. Oh. This is some weird shit. Seminar. Next one. This is. You're welcome. Thank you. And I think the phrase for this is not yet. So it says not yet on there. None of these ones I'm passing back, so not yet. other Daniel, what the hell? Brandon, pretty sure this is yours. Didn't get your name on that one, but I think it's yours. Let's grab it.
Yeah, let's do it.
Park.
Give me that.
Thank you, Alexander. Boom, boom. And Christian. So one thing I realized is it's kind of like hard. I think maybe even Alexander had said, like, I don't know how to prep for this. Maybe I should help with that. So I'm creating optional web work sets that will help you work. They're not for grade, but they will be available for you. So, and I will create some for this. So for like the folks who have to come retake it again, I'll create some web work sets. There are currently a couple web work sets up to start prepping for the next one. There's one on the cross product, and there is one about lines and points in space that we're, sorry, these are twosies. Lines and points in space that we're going to talk about today. Sorry. There. On this one you're getting back now, skill 4, one of the common mistakes was swapping what traces were in the X direction with the Y direction. Very common. I can address this in just a minute. This, I guess, has got to become more efficient. This is ridiculous. Daniel, are you still not here? Dude.
Promise you.
You hear that? People talking shit about you, man. You gotta get here.
He knows.
Alright, let's do your clock. And chronic. Yeah, so 9, this will say like probably excellent or freaking awesome. This says like meets expectations. This says revision needed, and then this says not yet. But you can look in the grade book to see the precise details if you're like, what is that word that he wrote there? Well, ask me or look in the grade book. It's always good to look in the grade book anyway and make sure your profs are recording things properly. So is there any questions on any of this? Like what needs to happen? I'll have office hours on Thursday. I'm gonna be giving some skills checks. Yes, sir.
Oh, okay. I was gonna say, you want to set up an appointment or you just want to show up on office hours?
Yeah, so office hours are great. If you can't make those, that's my Thursday office hours are gonna be flexi kinds of things, so.
What's the time on those? Do you know?
Probably on Thursday, I'm thinking like 11 to 1. I don't know if that works for you. And then Fridays, I'm always in the hour and a half right before class. I don't know if that works for you either, but. And then in general, I'm in my office the hour and a half before class. It would be cool if you could just email me and let me know if you're coming, because I have to print up a new one. Sometimes I actually have to create a new one. So just give me a heads up on that. That would be great. Any other questions or concerns, my friends? All good? Yeah, cool. I'm stoked about what we're doing today. Because we're talking about points and lines in space. I'm kind of thinking we'll have another skill check next week. You know, at the beginning of the semester when I gave you the syllabus, I had this grand plan of every other Friday being that, and I have trouble with schedules and rhythms. I like music, good with music, not good with life rhythms, not great about that. So we'll make these happen when they seem appropriate, like when we have a sufficient amount of material to do some. So points and lines in space, lines and planes in space is what I mean. Lines and planes in space, and I'm kind of hoping to take your idea of a line, even in just the plane, and give you a whole different perspective on it. But first, let's start with lines in space. So lines in, well, let's actually review some things here. Let's just talk about lines in the plane. Think about how we might think about those in the ways that we have already, and then maybe in some new ways. And I'm literally going to show you 2 new ways to think about lines in the plane. When I say lines in the plane, what's the first thing that comes to your head? What's that, Kayla?
Why is that supposed to be?
No, I like that. What other things come to your head? What? Yeah, that's cool. It could be. That was the start of a potentially great answer. There was. What other stuff comes to your head? What are ways to build lines?
2 dots. Shortest distance.
Yeah, that's it. So you get 2 points. Work from there. How do you generally get to this? So if I gave you a couple of points and I said, here's x1, y1, here's x2, y2, how would you find the equation of the line L in this form? So we need to find the slope, we need to find that y-intercept. How would you get here? There's lots of ways.
Point slope form.
Points, that's the other thing I'm thinking about. So point slope form, sorry, I'm spitting, Camille. I hope it's not hitting you. So point slope form is kind of our constructive method. This is an informative method. This is where you've got like a line, you put it in this form, and you can grab information from it. So I think of this as an information grabbing form. I think of point slope form as a constructive form. So given a point, x naught, y naught, and a slope, m, which is the classic slope. I'm not sure why, it's probably some German word. Does anybody know the German word for slope? I don't, yeah, anyway. It's something very German, no doubt. So to imagine a German person saying anything and put an M in front of it. So the way you do this is you've got a point, you've got a slope, and you write it like this. You say the equation is y, that's my variable, is the slope times x minus the x coordinate plus the y coordinate of the known point, like so. So that is how I would do this, but like, what do I need here first? What is the thing I actually need to make this happen? Daniel gave us, we got this line here. What do I need here, Daniel, like, to get to that? I got 2 points, I can pick either one.
Numbers.
Hell yeah, that's right. Anybody want to elaborate? Coordinates?
Just slope.
Slope. How do I find slope? Rise over run, yeah. So we got that, it's the slope. Choose y, change an x. Yeah. Cool, so for this one I would find the slope using, so I heard all sorts of things being slightly muttered out there. Y2 minus y1 over x2 minus x1. Find that, take either one of these points and use it as your point, and you're good to go. Yeah, sound okay? Let's think of a different way. Let's think about this in a vector way. So let's call this P1, let's call this P2. So another perspective on lines. This might be a little new. Wasn't hearing like a roaring like cacophony of answers to these things, so maybe this will be like really amazing. But you know this. You just didn't know you're afraid to say stuff or finish saying stuff or whatever it might be. So another perspective is we're gonna think about a vector form of this line. And so what I'm going to do is I'm going to create the vector P1, P2. So get direction vector P1, P2, and we want to make sure that we subtract in the right order. It's the where I'm going minus the where I came from. So I'm going to get a direction vector, and then let's just call this V here, so that I don't have to keep writing all that notation. So got a direction vector, and then 2, I'm going to use this vector form, which says that the equation is going to be described as the tip of a vector. So this is the vector, and its tip R is going to be the thing that describes where we're at on the line. So for example, if this is my line L, then this vector R of t is going to have a tip on the line. So the tip of RT describes the line. And the t is what's called a parameter. So t is a parameter. So good so far? Yeah? Any questions? Cool. Okay, so this R of t, the equation for this is it's going to be the point, let's say P0, and this is any point on the line, kind of like akin to what we had over there, where we had either x0, x1, y1, or x2, y2. It's any point on the line, plus t times the direction vector v that I formed up there. That's a very nice, elegant form. So let's do an example. And one thing I want to note that this has 2 components. So notice that this will actually be 2 equations. There'll be an x equals the p naught, the x coordinate, plus t times the x coordinate on this v, and then y will be p naught's y coordinate plus t times the second coordinate of v here. Does that look good? Yeah. And so maybe I'll make this even clearer that p naught is p naught x comma p naught y, and v is v1 comma v2. So let's do an example. Let's do a couple ways. We'll do it with first old school, do it with new school. So example, find, and this might also be called parametric form, which still has this vector information in it. Find the equation of the line through, and we're going to know the dimension immediately because we're going to see 2 points here. So let's say 1, 3, and 0, 1, 3, I'm just picturing this, 0, 5. Always draw a picture, right? We just, like, I don't know how people do shit without drawing pictures. Even if the picture is slightly misleading, it's always good to have a picture just to think. Takes some of the load off your brain, right? Just like math writing is technology, this is technology. It's some old ass technology. 1, 2, 3, 4, 5. So this must be the line I'm talking about. Let's call it L. So old school. Can you do the old school first and give me a y equals mx plus b form, please? And so simplify, you're going to do point slope, and then simplify it to y equals mx plus b form. So A is y equals mx plus b form. And we'll work through the second one together. So
Is that not 5-0?
yes. yeah, good. I said you're like, what is going on here? Sorry. Didn't match the picture. Good point. 5-0. Thank you, Evan. What did I do? Oh, it says describes the line, t is the parameter, and the r of t is a vector.
Oh, okay.
And the tip of that vector, each time you change t changes, the tip lives on the line.
Oh,
Does that make sense?
okay.
Yeah. And we'll see that, we'll show this example, kind of resonates that perspective. So hopefully you're getting a slope of -3/4. I'm going to use 5, 0, but you'll get the same thing with the other points. So you pick I'm going to take a 0 when I can get a 0, you know. If that looks okay. And apparently I need supervision today. Evan's keeping me straight on my drawings. Christian giving me a heads up and feeling good on that. Where does that line intersect the y-axis? 15/4, that's what this is, right? This B is the y-intercept. So that actually tells me at least one little bit of information that I had to figure out somehow, maybe. It's nice to know that intercepted times. 15/4, that's not 4, it's 3 3/4, something like that. Lots of 3's and 3/4. So let me know when you feel okay about this. And if you want, yeah, okay, cool. If you want, you can go ahead and start on this next one. But what is a question you might want to ask about forming the vector? What might we want to know? So let's go through this. So let's do the vector form. And we can come back to that if you're still not. So here, let's do the parametric form, vector form. I'm going to form this direction vector, V. What do I need to at least make a call on?
What direction you're going?
What direction this thing's going? So let's talk about what that's going to do. So now here, if I do this point, if I make my vector this minus this, then as time moves forward, I move this direction. If I make it this minus that, the vector's going to point in that direction, and positive time flows this way. So all the same points will be hit. It's just I might be trying to model a physical situation, and I want to know, I want my particle to move in the right way. So right here, we don't have any time info, right? We're not sure about what time this happened and what time this happened. So we have to make a call. As a righty, I'm going to make it flow to the right. And that's the sad conventions of this world. So I'm going to do 5, 0 minus 1, 3, keeping in mind that this will flow right as time increases. So I'll move to the right as time increases. I don't know, flow, it's got a flow word in there. So this is the vector 4, 3, which is nice and positive. Minus 3, thank you. Thanks. Yes. Good reaction. Good facial reactions, thank you. Now is it okay?
Yeah.
Okay, good, thanks. I need you all to help me. I told you I need supervision. All right, so that's my direction vector. Now I can pick either point I want. Why wouldn't I go with 0, 5? But I might have a reason to use the other point. We don't have one here, but you might have some physical situation as, what did I call it, P naught? Yeah, it's P naught. So now it's easy. My vector equation is R of t. I'm using a little hat. Notice this is a vector valued function, which we're going to get into more this week for sure. But this is a function of t that spits out a vector. I don't know what this is, but that's a vector, I guess. So this is going to equal p naught plus, what did I put first? T, v. And so that's 5, 0 plus t times 4 minus 3. And I'm good to go. This is fine right now. Every value of t will be a location on that line. But I could write this as a vector itself. So I could say that's 5, and you probably will want to do this more often than not. So 5 plus 4t, and then 0 minus 3t. So now we have an even more vectory looking thing there. It's compact, it's all together. For different values of t, I'm going to get different points. This will be where when t equals 0. So what is r of 0 always going to be? What does it spit out?
5, 0.
The point, right? It always spits out our point. So notice here, yes, so here it's going to be 5, 0. When t equals 0, you just get your point. So that's like home base. That's whatever you're considering home. That's why I said, depending on the physical situation, you might have that. And I probably ought to put a little hat on it. It's p naught treated as a vector. So then I can also break this apart and write this in this parametric form, which is x is equal to 5 plus 4t and y equals minus 3t. I put the little braces to make them look like they live together, right? They're a family. Okay, so I got one more way, but not yet. I gotta wait till we start talking about planes. There's one other way to think about making lines in the plane. This might even be something you think about, I don't know, with your vector graphics and stuff.
You should change colors.
Okay,
Yeah.
what color?
White,
Yeah.
green.
Bright?
Yeah,
Okay.
red.
These are mine
Actually,
anyway, I
don't
must have
use red.
left these here.
Those are subs.
Is it glaring? Is it hard to see it?
No, it's just you seem to mix it up sometimes. You got
You're right,
these nice
thank you. No,
markers.
you're right, you're so right. Let's just, and yeah, you're right, I spent all that money, almost forgot my clock. Bought these damn pens, yeah, I like it. Let's go to, not red,
Yeah, that's,
blue,
yeah, blue is good.
blue, how about this, like,
And green is
that
nice
blue?
too.
That's a nice blue. That's a nice blue. Okay, so, actually, maybe I will just show you the other way to do a line because it'll lead perfectly into planes. So there's one more way we could do this. And this is pretty weird, but it'll help make planes make more sense. So, one more weird way to get the equation of a line. And this is actually going to kind of lead us back to the y equals mx plus b form. But if you understand this, the planes are going to be so much easier. And I'm kind of betting you've never seen this no matter what class, no matter what. So, multi-colors, thanks Talon. What have I been thinking? Living like a fool without color. So, same kind of setup. I've got a point, P naught. But this time, instead of a direction vector, I've got something different. I've got a normal vector. So what I'm imagining is that I live on the line, I'm walking on the line, walking up it. I kind of want to know what is straight up. So that's what I mean by a normal vector to the line. And we can define the line using that, but we got to do it a little, we got to think a little bit outside the box. So I got P naught, and then I've got this normal vector n. Now I'm not saying it's a unit vector or anything, it's just a vector that points away from the line. And I want my line to be all the things that are perpendicular to that. So in other words, I'm thinking about, let me say this another way. If I drew a vector from the tip of the normal vector, in other words, from P naught, to anywhere else in the line, so let's say there's a V there, or there's a V there, let's call that W. So any vector that lives in that line, what is its relationship to n? Orthogonal, right? How do I determine if things are orthogonal? Dot product is the angle is 90, dot product is 0. So we have that mechanism of the dot product. When someone asks you about angles with vectors, always think dot product. So for any vector V that emanates from the point P naught and lives in our line, we have the normal vector dotted with that vector V, like I drew it up there, could be W here, I just wanted those to be different, equals 0. So, what does that mean? What is that going to look like here? And so what we need to do is we need this, we kind of want to shoot toward like X's and Y's. So what I'm going to do is I'm going to say, let's make the tip of that vector V X, Y. And then this P naught, we're going to do again, that's P naught X, P naught Y, like that. And so this vector V, I form it by taking its end minus its origin, and that's going to create the vector V. So it's X minus P naught X, comma Y minus P naught Y. X and Y are going to be our variables. And so what we want to do is we're going to leave this like this, and we're going to come to this equation, and it's going to give us a relationship about what X and Y have to be, what they have to hold true to be on that line. So let's suppose that n is just n1, n2. That's the normal vector form. So this equation down here, n dot v equals 0, what is that going to look like? It's going to be n1, n2 dotted with that vector y minus p naught y equals 0. And now I have like what you could almost call is like the normal form of a line, normal vector form of a line. I don't even know if this has a name. It was just when I was thinking about our stuff, I thought, well, this sounds cool. Let's do this. This seems cool to investigate, check it out. So now I'm going to do the dot product over here. And so that's n1 times x minus p naught x plus n2 times y minus p naught y equals 0. And now I've got something very different here. I've got n1x minus n1 p naught x plus n2y minus n2 p naught y equals 0. And I could put this into this form here. So n1x plus n2y equals all this crap on the right. So positive P N1 P naught X plus N2 P naught Y. So I've got that right there as the equation of a line as well. And so I could crank into that. Now, that form right there is sometimes called normal form of a line. It actually is. Now this is all starting to make some sense to me. Normal form of a line looks like this: AX plus BY equals some constant. You've probably seen that somewhere. But what are A and B now? What insight can we gain? Look at that equation of the line. What are A and B actually for the line, those coefficients?
And 1 and 2?
They are the components of the normal vector. So if you see a line like this, you know you can just compare that. You overlay this with that. You can see that AB, like this, is a normal vector to the line. That's kind of cool. I actually didn't even see that coming. That's cool. I love it when stuff happens in class that I didn't know was going to happen. So that's fun. So anyway, let me stop for a second. This is the idea that we need to understand to do planes. Because this is how we're going to figure out plane equations. We're going to have a normal vector in space. And what we're going to do is figure out the plane that it's normal for. And the way we're going to do that is we're going to take our plane. Let's just do it on the board. So let's say this is my normal vector right here. I guess new colors are needed. If this is my normal vector coming out of the plane through this point, here's my point, P naught, normal vector n coming out here, I'm going to figure out what all the vectors that are orthogonal to it look like. And I'm going to know their tips are going to be x, y. And I'm going to form these vectors, these arbitrary x, y vectors with that point that I know. And I'm just going to require this, that normal vector dotted with the vectors in the plane is 0. So that's the plane. Has anybody seen this normal form of the line? God, I don't. You have? Where'd you see it?
Like doing some diffy Q stuff.
Really? Interesting. Oh, cool. Oh. I guess it's okay. It's still cool. So let's do this for planes. And then we're gonna have some fun. We're gonna crank out some stuff. And find intersections, or maybe not intersections. Oh, yeah, actually, let's do that before we go anywhere. I made up a problem that I want to do, and I want to see what you think of it. If I can find it. Okay. Probably gonna take a couple of days on this plane line stuff. Spent like 3 hours yesterday helping a undergraduate math student who's also my dog sitter and a good friend. She's out in Pennsylvania being poorly advised into math classes she shouldn't be in yet. So we worked on a lot of abstract algebra. She was pretty miserable. You ever been in a class you felt like, I shouldn't have been in this yet? Hopefully that's not this moment, don't tell me. Okay, so here's 2 lines. Here's L1 that I'm going to give you in this form. And actually I think we'll just talk about this, but I will have you do one thing first. And then I've got L2, which is in vector form. So this is parametric form, this is vector form. Oh shit, have we done 3D lines yet? No, that's why this is weird. Hold on. That's what's missing, the 3D shit. I just like been grooving on 2D. So, lines in space. No wonder this is going to take several days. Lines in space in R3. Same thing. Got a point, got a vector. Look at all the multiples all along the way. So here we're going to have, let's get some 3D space out there. I've got a point, P naught, and let's call that X naught, Y naught, Z naught. I don't know why I've been coming up with weird notation, I apologize. Sometimes happens. And I've got a direction vector V pointing somewhere into space. The line L defined by these 2 points is literally the same equation. That's what's kind of cool about writing it this way. It doesn't even, you don't need the dimension to be known. It's the same rhythm. The coordinates of the point that's on the line plus t, this is our parameter, so let's make sure we know. Parameter, P naught is any point on the line, and V is our direction vector. So with that being said, we can work our way up to this problem. Do me a favor and please find the equation, the vector equation of the line through, now I've got to kind of like back up here. So this is going to be 8, 5, 4, and we'll make life easy. 10, 17, I know that doesn't seem easy, but it actually isn't too bad. 17, and then 0. Can you please find that line? Do that. And do it in this vector form. So just get to this, just do this. Find the direction vector. So I'll start doing the outline if you're kind of like, what? I don't know what he's talking about. Step 1 is find the direction vector. And let's use this, you can use them either way, but let's use this as the direction we're headed, and this is where we're leaving. So we're headed from 854 to 1017.0 as time moves positive. That is a positive 12, thank you, yes. Thank you. Thank you for monitoring as always. That's good, safe. Let me know if you're okay, and so your next step then is to write R of t equals, pick either point. I'm gonna, since we said we're originating from 854, that's the point I'm gonna use. Then distribute that t across the vector, and pull the components together into a solid vector. Yes, ma'am. Then I have a question for you. You can just think about for a second while other folks are getting that. At what time do we hit 10.17.0? We see t equals 1. So if I asked you, when does this equal 10.17.0? When does that happen? All you have to do is pick one of the components and figure it out. I like this one. When does 4 minus 4t equal 0? When t equals 1. Then I check to make sure that I did this right. When t equals 1, this is 17. When t equals 1, this is 10. So that's consistent. So that's at t equals 1. Okay, everybody cool? And then at t equals 0, I'm here, right? At t equals 0, I haven't added any vector on, and I'm right here at home base. Let me stop. Is this cool? We good with this? Yeah? All right, I'm gonna give you another line, and I have a tricky question, and I just want you to suffer with it just for a short period, very short period. Does this line, and actually here, let's write it as parametric form. So x equals 8 plus 2t, y equals 5 plus 12t, and z equals 4 minus 4t. And I just like putting those braces there. They're optional, but they're nice. Says it all goes together. So we'll call that L1. And then here's L2. And L2 looks like this. Now let's see. So L2 is x equals negative 7 plus 12t. I'm going to ask you a few questions about these things before we go on. One's super challenging, but we'll warm up a little first. So let's move backwards just to make sure we're feeling okay about this, and I'll change colors. What is the vector form of L2? This is like R1 here. Just take a minute. What is the vector form of R2 given the parametric form? Just doing doing some calisthenics. Pink and purple. That's what we need. I'm doing something, I'm just being chumpy here, but I did it for a reason. Is that right? Doesn't look right. What's wrong? What's Athman? You're saying what's wrong there?
Just it look weird to me, I don't know.
This looks weird. Yeah? Do you see where I got this from?
Yeah.
This is the vector of motion, right? This is just a different point on the line. I just was like being playful, and I picked a different point on the line to anchor from. You can pick any point. This is the same line. In fact, when t equals -1 here, where am I at?
7, -3, -18.
Yeah, I'm back at the other, right? I'm at this point, -7, 3, 18. Did I do it right?
Oh, yeah.
Yeah, cool, got scared. So just to know, you can use any point on the line, and that was why I was doing this, just to entertain myself and maybe you slightly, hopefully not confound you. Here's what you probably did, and this is totally awesome, because it's the same information. So if you took the anchor, well, shit. It's okay. I've had a lot of tea. And it didn't all spill, shockingly. It's kind of weird. That's a good mug. How many folks did this? Yeah? Does anybody want me to explain how I did that?
So you actually
Yeah.
explain.
Yeah, totally.
No, explain the T, the 12, -180.
Yeah. So the vector of the motion, so check out here on the form, Alex. The T is times the vector. So,
Right, I got the form now.
you got that?
Yep.
Cool. So, do you see that when I looked here, I just looked at what was moving and took the coefficients, 12, -1, 8, and those must have been the vector.
Obviously.
Thank you. It's not obvious. Thanks for asking. Thank you. I'm sure there's somebody else, honestly, who probably didn't ask. We should have. All right. Any other questions? That's a good question. Cool. So now, so I now have a worse question. Do these two lines intersect? I don't know the answer. Why don't you take a minute and see what you think? And think about it. How might we answer that question? And I would just have, just think for a minute. Just think for a minute. And maybe write some shit. Try some shit. Bless you. This is a non-trivial problem. You might think you know what to do. But I bet your intuition, your first intuition, is not the way to go. So let me just, if that question doesn't make sense, is it possible to achieve the same X, Y, and Z coordinates using these lines? Is it possible that this one and that one at some point pass through the same X, Y, Z spot? And I will just give the hint that it might not be at the same time. There you go, that's the erase. It might not happen at the same time, but it still could happen. Write some shit. Let's pretend we're at math club.
This is math club, isn't it?
This is pretty much, yeah. A math club. Yeah, actually, I gotta remind myself to ask about that. Because I'm sick of running math club.
Come on.
No, I am. No, I'm sick of it. No, I want something else. I want something different to happen. I want math club to live.
Does that mean you're never coming again?
No, I'm just, yeah. Sometimes I'll come.
I guess I'm like thinking of it as like.
I want it to be running on its own. You know what I mean? I don't want it to be like, be entertaining today.
Yeah.
Yeah, it's old.
Oh, that's right.
Yeah. So I think we can do it. We've done it in the past, and then COVID hit and everything died. Kind of miss COVID. I like staying home.
Tread lightly with that.
No, I like staying home. I don't want another bath. I just want us to all stay home. I just want me to stay home.
Oh.
Hang out with my dogs.
You're close.
What's that?
You said you're close. Can't you retire in like the next 6 years?
We'll see. We'll see how it goes. Does anybody have any ideas on how to proceed?
Maybe find the unit vectors and see how they match.
Okay, well, let's try that.
If they're in the
So,
same direction or not.
yeah, let's grab some vectors here. So, see if they're in the same direction. Do they have to be in the same direction to intersect? This is a great line of discourse. This has a direction. Let me take it. Can these two intersect?
No.
No. So if they have the same direction vector, they either don't intersect or what? They freaking are the same line.
Oh, yeah.
Yeah? Could even flips it So that won't help us unless we think they're the same line.
Okay.
Does that make sense?
Mhm.
Yeah. So, and we can kind of tell, we can almost kind of suss out that 212, let's look at the vector here. It's 212 minus 4, and then this one here is 12 minus 1, 8. So for their unit vectors forms to be the same, one has to be a multiple of the other. I have to be able to multiply this by some number, a scalar, and have it look like that. But I can see that if I to get from 2 to 12, I gotta multiply by 6. But when I take 12 times 6, I don't get -1. So if this was 12, 72, -24, then that's gonna work out. In other words, if they're all the same multiples over there. Yes, Kayla?
So if they're intersecting, does that mean that one of the coordinate points would be like this, like both x's would be the same?
Yes!
So couldn't we set the x's equal to each other and the y's equal to each other and like z's equal to each other and solve for t?
We can, but again, they might not have, let's try that and just see what happens, because that's what you might think at first, right? Like, well, the x's have to be the same. So, and you're right, that actually is the key of it, that the coordinates have to be the same. But if I set the x coordinate equal here, so this is the x equation, let's just get them all up here, and then the y equation is 5 plus 12t equals 3 minus t, and I do have a clock these days. And then z is 4 minus 4t equals 18 plus 8t. So we could solve one. Let's see what this top one says. So if I solve this, this is, I'm gonna move the 7, that's 15, move the 2 over there, equals 10t. Just solving this for t, which says t equals 1.5. Does t equal 1.5 solve this?
No.
So when the x coordinates are the same here for that t, these aren't the same, and these aren't the same. Yeah,
I
Evan?
would just solve for 1t using 2 equations, I like subtracting them.
So say more.
Like take, I guess, I don't know which ones you deal with, but maybe the top 2 and multiply the top equation by 6. So there's both 8 plus 12t, 5 plus 12t.
Oh, you're thinking like combining them to like, yeah, that's, well, let's see. So let's try that and see what happens. So multiply this one by maybe 6.
Yeah.
Yeah, so if I multiply this one by 6, ooh, that is a good color. That is 48 plus 12t equals -42 plus 72t, and then subtract.
Yeah.
So then we've got that, which is 43, 0 equals -39. Wait, am I subtracting, right? So -45 plus 73t. That looks pretty atrocious, but let's see. So I've got 73t equals 88. So t equals 88 73rds.
Yeah, and then we could solve for the other t.
So we only have, the t has to kind of, the way I've got these written, like if I put that in here, does that solve this one? Does t equals 88 73rds make this true? Probably not. It looks like it doesn't, right? And it looks sucky to check. I don't think it does. I don't know if I even want to try because I gotta multiply 88 by 4. That sounds horrible. So that, I will say that method, no method where we only have one t can work, because these lines are on different schedules. This line, this might be t equals 0 on this line. The place where I'm headed might be t equals 0 for the other line. So I might have these two lines in space, And just because of the way they are parameterized, I might have L1 and L2. On this line, this might be t equals 0, but on this line, it might be t equals -7 or 5. I guess that's what I'm writing. So what we need to do is set up 2 timescales. We have to make 2 variables, and that's how we do this. And then, Evan, then we can actually use your idea. Then that will work. So what we're going to do, and what you're going to do, and remember there's some wet work problems if you want to take your hand at this, is we're going to use T1 and T2, and we're going to figure out what T1 and T2 have to be to make these true if we even can. Because not every line intersects every other line. They might not intersect. And we're going to find out though, because we'll end up with something that can't be true. So let's make these the T1s. Let's make these the T2s. And now we're going to go down Evan's route. So notice here, I've got 2 equations and 2 unknowns. I'm going to solve for T1 and T2. I'm going to check those down here and see if they work on this one. So let me show you the rhythm, and then I'm going to ask you to do this. I'm going to ask you to just start cranking on this, and then of course I'll join in. I can't let you have all the fun. So solve the system for T1 and T2. And then check it here. Then check to see if those T1, T2 values make the third equation true. You could use any 2 of these you want to do this. Let's check it out. Let's see what happens. But Evan's route of canceling things, that's totally the way I would go. I would try to cancel the T1 out of this, subtract, if I take right multiple, subtract, and then you'll find T2 right away. Yeah, we're probably not getting the planes today. Do that on Wednesday.
So would you not multiply by 6?
No, that is definitely what I would do.
Oh.
Now it's going to work out.
That's what I was trying to get to earlier, because
Yeah, you had the right idea. You just couldn't do it with only one variable.
Right, yeah.
So that was good thinking, for sure. Looks like I might have to do horrible things after all. is horrible, but nonetheless. No, that's wrong. That's that 88, isn't it? Yeah. You can add that. You shouldn't be afraid of fractions. You'll be alright.
You're alright, you're gonna get strong.
Brave.
I conquer.
But what we don't want to do is get our calculators out. Because then we've caved in to the man. Then the man wins. They want to sell you calculators. They want you to not know how to do things. Did I do that right first off? Did anybody else get that? Ooh, checks. Yeah, you got some different? So cool. Thank you. So what did you get, Camila?
I got 73.
73. So let's see. So I took 6, because it's plus. Thank you. Yes, ma'am. Good stuff. Thank you. Still, good Lord, but just a different good Lord. Anybody else get that? Yeah, Ahmed.
Can you just tell me what you did, like, explain that?
Yeah, took. So I'm gonna label this equation 1, label this equation 2. I wanted to cancel the T1s out. So I took 6 times equation 1 minus equation 2. So 6 times equation 1 is 6 times 8 is, that's where the 48 comes from, minus the 5. 6 times this is 12T1, so that's where you see 12T1, minus 12T1. You see? Does it make sense now? And then the other side, same deal, same deal. Good question. Other questions? Cool. So now I can take, yes, sir. What's that?
You're subtracting the X and the Y components after you multiply twice. Oh, yeah.
Yes,
So
yes, I am, yeah.
Okay, of course.
Yeah,
Yeah.
that's okay, it's all good. You don't have to, of course, yourself. It's all good,
Well,
it's good
I
stuff.
saw it as.
Okay, cool, all right,
Obviously.
All right. That word, like clearly and obviously, like there was a time when math books would have those in them all the time, right? It's like clearly, proof is left to the reader, it's trivial, the word trivial, and it's just like, oh man, so arrogant. So arrogant. So how do I find T1?
Plug it back in.
Plug it back in. Hell, I'm going for that second equation over there because that just looks a little easier. So to find T1, plug T2 equals 88/73 into one of the top 2 equations. I don't want to do this in that bottom equation yet because that's my checking equation. Into equation, I'm just going to say equation 2. It doesn't have to be, it could be, or 1. And so what we get is 5 plus 12T1 equals 3 minus 88/73. This is no reason to fear. So this is 12T1 equals 3 minus 5 is -2. Minus 88/73. 2 times 73 is 146. So this is negative 146/73 minus 88/73. This is what happens when you make up problems and don't work them. It's like real life, right? It's just miserable. 12T1. And then, oh my gosh, negative 2, yeah, they help me out.
234.
234, thank you. That sounds so good. Over 73. Does 234, does 12, I don't think it goes into there.
It's 2808 over 73. Right.
Wait, how'd you get 2808?
You divide by 12.
So T1 equals
So you're
12 times 73, right? So the 12.
Oh wait, yep, no, that was wrong.
That's okay. This is divisible by 3. So let's fix that. How do I know that's divisible by 3?
All the numbers add up to.
All the numbers add up to a multiple of 3, exactly, they add up to 9, so I know it's divisible by 3. So 234, yep, you're gonna watch me do this, 78, so that's negative 78 over, and I took a 3 out, so that's 4 times 73. Why do I feel like that's divisible by 4? It isn't. It isn't. So that's about as good as we can go, but it's slightly better. Negative 78 over 292?
Sure.
Yeah?
Yeah.
Yeah, right, sure, yeah. Sounds good. So that's T1, we've got T2. Now all we have to do, which actually seems like a lot, is plug those in here and see if it's true. If it's not, okay, so let me just say this. If it's not true, we might have fucked up. That is completely possible. But with all of us here watching, I believe in us. If this equation turns out to be false and everything we've done is right, then they don't intersect. Okay? So at this stage here, so after finding T1 and T2, plug into the remaining equation. Let's do a little computer programming here. If it is false, then lines do not intersect, with the caveat that we did everything properly. Do not intersect, else we got it. So we have the T1 and T2 values, we still need to figure out what point they correspond to. So we need to go back to one of the 2 equations and plug them in, and you can just go for either the T1 or the T2, because that'll work. So you take your T1 value, plug it into one set, get the X, Y, Z. Let's just see what happens here first. So let's check Z. So we've got 4 minus 4 times.
Negative 78 over 292.
Thank you. And I'm going to put equals question mark. 18 plus 8 times, what was the beast?
88 over 73.
88 over 73. Get busy, calculator. Somebody tell me. Somebody tell me. Somebody do the left side, somebody do the right side. Let's see what we get. And if it's decimals, okay. Well, I'll take decimals. Because I don't think this is good. Anybody got a left side for me? Anybody got a right side for me?
Right side,
Right side, what you got, Camila?
27.6438.
And is that really it then?
No, 35616.
I'm just gonna do it, and then it probably keeps on going.
It stops right.
Oh,
64. It stops at 4.
so 6, like that?
Yeah.
Okay, cool, awesome. Left side foot. Make Camila do it all. At least it's gonna be positive, so that kind of looks.
I did the left side, but I got like 5.068 and a bunch of decimals.
Yeah, I just got that too.
Okay, cool, what'd you get?
5.0684931507.
Yeah, we can stop, I think. Yeah, and you got that also? So what can we conclude?
We did it right.
That they don't intersect. Let's just work with that. And on Wednesday, I'll come with a better example where they do intersect. And there are some on web work where they do. So because of this, these are not equal, so the lines do not intersect. That's all right. At least we're all together for that, right? It's good to have emotional support. That's the end. This is 4:13.
Okay, right.
It's 3:37.
Thank you.
We're an hour over.
Clock's an hour ahead, yeah, that's good.
I noticed that other one, it's
Oh, thank you. Yeah, thanks. Okay, it was true the other day too. It's not like a bunk clock. All right, friends, I'll see you on Wednesday. Web work available for your practice. It's not for credit, but if you want the next skills checks to be easier, do a little every day. You'll be happy. Did you get a chance to check out that video I sent you?
Yes, I did.
It's good stuff, isn't it?
Yeah.